Welcome everyone. I hope everyone can hear us. We are getting ready to start. This is session number 2 of the A320 programming class. I'm hoping everybody can see my welcome screen here. It says our event will start soon. Again, this is session 2. We have quite a few less people than we had this morning. We had some people that maybe they're not clear about the time zones or something, but nonetheless, we're a little less than we were this afternoon, or I'm sorry, this morning. So again, your instructor is going to be Phan, and we encourage everybody to, put the comments in like they were before. So there's a picture. So it's almost like a question. It's right to the right of the hand. If you press that, that's going to show conversations, and you can type messages in there. And we will do our best to field all and any questions during the presentation. We'll stop from time to time to take questions, and we'll do our best to answer. And then just to remind everybody, session 3 will be tomorrow morning at 8 a.m. California time. Session 4 will be tomorrow afternoon again at 12:30. So I'm going to go ahead and turn it over to Phan, your instructor for the A320 Type 7 programming class. Go ahead, Han.
All right, good afternoon, everyone. Thank you for coming back for my programming class today. So we're gonna continue with the session 2. I'm gonna share my screen right here, and basically it's gonna be the same book. Oh, no, not this. Share the program. Okay, so everyone see the program structure on your screen, right?
Yeah, we do.
All right, thank you for respond. Okay, so the machines running the NC program, as we know that is not just only the hard code that we call right here the main program body, but it's also collecting all the data from the MC data, which is we went over this morning already. And then the next thing is also running in the background is the tool set data, which is where you set up all the tools, the core, diameter, longitude, so on and so forth. And then the main program over here, we're gonna have like all the things that we're gonna need in order to command to run the machine, which is gonna start with the program number right here, and then we're gonna have like section right in the middle contain like all the toolpath and everything like that, and a cut off, and then it end up the cycle stop, which is going to be like this. So the program you're going to see, you're going to have $1, $2, the machining data, tool setup like this, and then going through the machine processing like this and cut off. So before to run the machine, we have to have a very good plan how we're going to do, like which way we're going to process in order to make the part like completely. And then so we have right here a few questions for you in order to have an idea in the future if you want to start programming or doing anything and you have in mind, okay, basically you're going to answer some questions right here. Is that like, is there any ID work required? Okay, with the Cincom machine, if there is any ID work, for example, like drill, tap, boring bar, anything like that happening in the ID work, you need to get it done first before you move on the OD work. And then also for the OD work right here, remember, we're not gonna do rough and finish pass. Everything has to turn in one pass. Since we have the guide pushing is support the material, so we able to run it in one shot. And then it's also another thing is according to the guide pushing length width, which is normally about like 3/4 inch, but then you can order special guy bushing, and then they can make the length up to like 375 longer than what it's supposed to be. And then so on so forth. You just go down the line, you're gonna ask like answer more questions about, okay, is there any back turning required to do it, or live tooling or secondary tooling machining in order to get involved in order to make your parts. And one more thing is not really less important, is which way you're gonna process first. It has to be working on the main spindle if it needs like the tight tolerance. So whichever way that require more tighter tolerance, you're gonna put it on the main spindle in order to machine it. And then also, nonetheless, right here, we also need to know, okay, if the material is too small, and then somehow we need the guy pushing is with extended nose collet or something like that, we also have to put it on too. And then after you done with the main spindle, you can move on to the sub spindle and then answer some questions down here, as you can like see it, and you try to answer it by yourself later on when you do a program. We're not gonna go over detail of this. So I talked earlier about for Swiss machine, especially for the Cincom machine, we're not gonna do roughing and finishing. We're just gonna turn only one pass and then finish the OD. And the reason why is right here. You can see the length inside the guide bushing right here, it limits, and like I said before, is a little bit over than 3/4 inch. And then you can order it in order to have this length is standing out if you need it. But then normally you not gonna turn it rough like this and then come back in order to finish this, because if the length of the part is more than the length of the guide bushing right here, you can see the material right here, it fall out of the guide bushing already. And right here, if it fall out, it become floppy and it's no longer accurate. Okay, and then another thing that we should talk about that is, okay, I mentioned earlier, any ID tool, it has to be finished first before we're going out to the OD, because when you're done with OD already, and then the part kind of longer than the length of the guy pushing, and there's no way that you can retract it in order to finish the work in the ID work. And one more thing to support for the idea is, when you're turning in one complete shot to finish the part, so when the tip of the tool right here is contact with the material, it's going to generate a lot of heat during the body of the part right here. So if you just cut a tiny bit by the tip right here, all the heat it's going to generate and then focus on the tip right there. So it's not going to be good for the tool. If you're gonna cut the whole section right here up, so the heat is can spreading out. It's spreading out for the whole like side right here of the insert. So the heat it can release from the tip of the tool. So that is another way, if you choosing the right RBM and the feed rate, and you can have a better tool life. And then one more thing right here, we want to say, okay, never pull the stock into the guide bushing completely. Do not do that, because when you pull it completely into the guide bushing, out of the guide bushing, you're going to lose the support from the guide bushing, and is no longer support, so you lose the rigidity and concentricity, something like that. But then somehow, if you're gonna have to pull it back from the guide bushing, make sure what you're gonna do is you're gonna need to apply a chamfer right here on the part. Okay, I'm gonna say the chamfer right here, you can apply as much as possible. And the reason why we have to put it right here, because sometimes if you come in and cut it, if you access the tool right away like this, it's gonna create a burr right here. And then it's gonna hard for you to pull it back. And for some reason, if the burr right here is too much, and the machine cannot pull it back, it will give you overload alarm. And then it's just only because of this. So I really highly recommend, if you have to pull the material back into the guide bushing, which is you're gonna have to do it sometime. So make sure you turn the OD and then make a chamfer and then go a little bit over before you move your tool out and then move home. Next thing, we're going to talk about how we're going to operate the parts, how we're going to programming it with a lot of feature like this. So you can see this part, it had turning, it had grooving, and it had the hole right here has to be made by the live tool right here. And then we're going to have another groove, OD turn groove, and then so on and so forth. So if your part is gonna have a lot of feature like this, we're gonna have to divide it into a small section, and which is we're gonna call it here is segment the work piece. Which is what you're gonna do. You see, okay, this is the order how we're gonna machine the part. So first thing, we're gonna come in with the turning tool, which is we're gonna turn the OD right here, step 1. And after that, you're going to use the roofing tool right here, come in order to make the roof right here. And then after the groove right here, you're going to come back with this tool right here in order to keep turning the OD again. And after you finish with OD again, you can come back with the live tool right here, which is in this case is a thrill. You're going to thrill the hole right here. And after that, you can use this one right here as a roofing tool in order to make the roof again. And then it's keep going on and on down the road until you finish the part and then you cut it up. So this is we call segment the work piece. The reason why we have to do all of this, I think I already mentioned before. But then, for example, if we have the parts, it's about like 2-inch long, and then if you turn it all the way up down to a cut up tool right here, and the length inside the guide bushing we know it's just 750. That means if we want to do the roofing right here, there's no way we can go back, retract the material, and still have the guide bushing support the material. So that's the idea why we have to divide into a small section in order to complete the parts. So this is a sample right here, the part that we machining for a customer not so long ago. So as you know, the diameter of the material right here is 3/4 of an inch. And then the finished OD right here is 1/8. And then this one we turn it in one pass only. Sometimes you just have to believe it and do it. And then with this part also, as you can see, we have to do section. So basically you're gonna turn the OD, small OD right here, and then put the undercut in here, and then thread it, and then come back to do all the OD work right here. And after that, we're going to cut up. It's just right here. So on your screen right now is program structure. It's been making by Bailey, one of our engineer. So he make a very good job in how to lay out everything in order to sync from the main spindle to the sub spindle. As you can see right here, it's syncing between main spindle and sub spindle, which is 630. And then later on, if you're gonna make the program, I recommend to use this one at a template, and then you can follow like what happened in here, and then maybe you can change the G600 right here into whatever mode that you want to use later on. But then the beginning of the program and then the end of the program, which is the pickup, it will remain almost the same. All we have to change is the position of uh, the material, like position out, and then where you're gonna come in to pick up of the parts. Other than that, everything else just lay out very nice and neat right here. As you can see on the template right here, we also have the G999. All right, let me blow it up a little bit. So G999 right here and N999, which is the last part programming, and then I will explain it later on further with the class. So one thing that right here you need to pay attention is the start position right here. Since we're reading this one and then remember what we went over this morning, we can see the location of the Z right here is minus 500,000. So that means we're gonna using for this particular template is a right hand cutoff. If you're gonna use a left hand cutoff, so this number right here is gonna be positive number, and it depends on what side of the thickness of the cutoff insert that you're using, and then the position gonna change. But then I mentioned earlier, I don't know you remember or not, but the starting point right here and the return point right here, which is the end position, it has to be matched. If you have right here minus G0, G50, X minus 50, and Z minus 5,000, which is this one. And then at the end, after the cutoff operation, you have to return the machine back to wherever you begin. For some reason, if you don't put the X right here, and then at the end right here, you shouldn't put it. Because some cases I already see that we have the alarm that position doesn't match with the start and end position. So if you don't put it right here, then don't put it down here. But if you put it up here, make sure you put it up down here also. Yeah, like I said, this template is a completely reduced program that you're gonna use in the future. So all you have to do is filling right in the middle right here for all the toolpath that you're gonna need. But then everything from beginning right here, all the cut up right here, it should look exactly almost the same. Of course, you're going to change something in here, but something that you cannot put from $1 and then put in $2. For some example, it's just like M94 right here. On the Mitsubishi control, you can have M94 either on the $1 or $2. The machine it will take it and then will not give you any problem, any alarm. But then in Fanuc control for this A320 machine, you need to put the M94 in $2, and some other M codes is also like M34. You cannot put it on the $1. If you're gonna do that, it will alarm out. Alright. So I have attaching with the manual a lot of parts, just like example for you to practice to see how it's gonna process, how you're gonna do it. For example, this part right here. So just looking at the picture, you can see we need to do the spot, and then we do the thrill, and then we do the tap. All of this is the ID work. So remember the number one rule, all the ID work has to be finished first before we go into the OD work. So right here we have all the ID work is state from 1 to 3, and then after that we can do is phase, turn, and thread major right here is right here. And then after that we're gonna thread it with number 5. And then after that we're going to turn the rest of the part right here. So same thing for the next part. You're going to see right here at the front side, looking at it, we're going to have some like roofing right here created by the saw. So basically we're going to do same thing. We're going to have to do ID work first, which is spot, drill it, and bore it. After that we can do the OD turn, which is face and turn, but then face and turn, which is face and turn to here, and then we stop because we have to use the slot slit and saw right here to create a slot, which is we're going to use the secondary tool, which is the live tool from tool number 6 to 9. So after that, we're gonna come back and then reboard to the burr. Okay, so right here, as you can see, we have the step number 6 that reboard, that also the ID work. But then why we do the ID work after this one, and then I can tell that the length of the part is not too long, that we can still retract inside the guide bushing. In this case you can go back and then do the ID work right here with no problem, but then that's not a good recommendation. But right here what we're gonna do, we just rebirth it only the section right here on the top, so we're not really doing anything that critical. So in this case it's acceptable. And then moving on to the next thing, what we're gonna do is we're gonna do return to debird the OD right here. So return it, and then we can go back here and do the reslot to debird it also. So everything we're doing right here, to make sure to drop off the part that completely burr free, so we don't have to go over deburring department or doing anything secondary option that you need to do. And then the last thing you need to do is turn the part completely right here and done with the parts. Okay, so do we have any questions so far? No? If not, we're gonna keep moving on. Okay, so here we have some more example right here for you in order to practice later on. As we can see, okay, we have the part with roofing and OD turning, something like that. And down here we have part with which is required a secondary tool in order to involve. Okay, for this class we're gonna use this part right here, which is we call the knockout pin, or you can call it ejector. in order to practice to do programming. We're going to start planning how we're going to do it, how we're going to approach the part, which way we're going to do first, and then how we're going to make it in order to turn into the complete parts. So this is going to be the project that is going to go through the whole class. So and then this one is also useful for the machining, because you can like change the OD right here and then make it whatever size that you're going to need in order to knock the part out of the sub spindle to collect the parts. So first thing first, we have to plan what we're going to do in order to make this part. All right, I zoom it a little bit bigger. Okay, so this part, look at the length of the part we're gonna see is about like 2 inch and for 47,210. So we're gonna plan where we're gonna pick up the parts, and then what side we're gonna do first, what tool we're gonna do. That's some kind like questions that you want to ask yourself, and you want to answer it to have a good plan before you start. So for me, it is a good idea to start this way first. And the reason why, because the diameter right here, we can come in and pick it up all the way to here without no problem. Compared to this side, if you want to machine from this side right here, you have the front OD right here is smaller than the portion right here, and then in the back side right here you have another diameter which is smaller than the section right here. So to make this way, is still have a way to do it, but then you're gonna need to purchase the over rib collar, which is have to be like special design in order to go over this one and then rib on this side right here, which is not the correct way to do. So we all agree right now is we're gonna machine from this side right here first. Okay, so we have a plan. We can come up with, okay, what side of the material we want to run this one. Okay, the finished OD right here is 39 and 36. That means 3093 and 610. That means we can use anything bigger than that in order to put into a machine to make the part. But then remember, it has to be less than 20 millimeter, because this machine, it is A320, and then 20 is represent for the max OD we can throw into the machine is 20 millimeter. One more thing, just practice common sense, which is we don't want to go with the OD is too big and then we have to turn it really hard in order to like burn out your tool quickly. So maybe we're going to the next side, maybe ½ inch, or you can think of any smaller than that. That's standard, that you can easily get it from like material supply, whatever you want to need to purchase, and then make it happen. So in this case, we're gonna stick with 500,000 for the material OD. So the first thing we need to purchase is the guide bushing. So the guide bushing, we need to have the guide bushing exactly the same size with the stock material that we have. And then the stock material, it can be smaller than the guide bushing a little bit, but not much. But then the guide bushing cannot be smaller than the stock diameter. Okay, so after we settle down, like we're gonna have the guide bushing side for ½ inch. The next thing we're gonna do, okay, we're gonna say how we gonna machine this part. So you see right here, we're gonna have to maybe spot it with a spot drill. But before we do the spot drill right here, we have to face it to give it a good face right here, which is I always do it before I drill. So, and then after that, you can drill it maybe all the way right here with the drill, the long drill. But then, is it necessary to drill it all the way right here when the machine, when the part is not really asking for the dimension right here for the ID is not really that critical? So maybe we can break it down right here, about 2/3 of the parts. Do we have some questions over here? Do we have any questions here? I see it's like, okay. If not, we're gonna moving on. Okay, so we're gonna plan. Oh, oops, this thing was moving over there. All right, I'm gonna just delete it. All right, I'm gonna repeat it right here. So first thing first, we're gonna need the guide bushing, but then we're gonna need the facing tool right here, and then the spot drill right here. And after that, okay, we're gonna drill it right in the middle right here, somewhere about 2/3 of the part. And then after that, we already finished like the ID. We're not gonna need to bore it out, so we just keep going and then going back with the turning tool right here. So the turning tool, we can turn it all the way up to here. And then as you can see on the side of the print right here, we have two flat right here, which is requiring we using the live tool in order to make two flat right here. So next thing we need to know is, okay, we need to use the live tool in order to do this. And then in the back side right here, I can use the back turning tool in order to make this section, like roughly turn this section right here in order to make the sub spindle work less, so it won't like because the sub spindle is gonna have less power than the main spindle, so we don't want it to work really hard in the back right here. So maybe we can just plunge it down and then turn it right here to relieve a little bit material. And then after that, I don't see that we have any other operation for the main spindle, so I will go ahead and cut it up right here. And then that's all the plan for the front side. And in the back side right here, since we know that we machine this side first, so we have to plan to get a collet in order to put in the sub spindle to pick up the parts. So this is the side of the OD right here, and then this is gonna be the side that you want to order for the collets that you're gonna have to put it in the sub spindle in order to pick up the part. Excuse me. Okay, so in case you're gonna order guide bushing and you don't know the number, so the collet is gonna be TD25. Oh no, hold on, TF25. And then the guide bushing is gonna be TD25NS. That's the guide bushing right there. Okay, so we need to plan in order to get the pickup collet right here with this side right here. in order to have it come in with the sub spindle and pick it up. So we can pick it up all the way to this point right here. So what is gonna have left for the sub spindle? Okay, so we plan it drill like just 2/3 of the part right here. So in the back side, we still have to drill it. So we're gonna have the left hand boring bar in order to do facing, and then turn the section right here. So for the sub spindle, you don't have to follow the rule is ID first and then OD last, because it's only applied for the main spindle, which is using the guide pushing unit. And the reason why you cannot do the OD first, because we retract into the guide pushing land. But in the sub spindle, it's totally different. You can do the OD first and then come back to do the ID, no problem. Either way you want to do. So right here we need the left hand boring bar in order to turn this section right here. And then after that you can just thread it right away, or you don't want it, you can like just spot it right here. When you spot it, and then after that you're gonna drill it. So we're gonna drill to the rest of it, maybe a little bit over, in order to clear right here. So that's what we're gonna do next. And then after that, we're gonna come back and then make this one right here with threading. And after with threading, we might have to go back to deburr it one more time and thread it one more time. It's up to you. And then we can eject the part after that. So that's the plan, how we're gonna do this part right here. So we're gonna go ahead and try to sketch out what tool we need right here. All right, I'm gonna switch to the OneNote, and then we're gonna, okay, right here. All right, I hope you guys can see the OneNote screen that I have it right here. If not, let me know.
Yep, we see it.
Okay, good. So we're gonna come up with a plan how we're gonna do it. So first thing first, we're gonna have the cut up tool, which is tool number 1. It's gonna be cut up tool. And then we need to turn the OD, so we're gonna have the tool number 2. So OD turn. And then we need the spot drill. So the spot drill, then you don't have any place to put, but again, the dog legs, which is the tool from 11 to 14. So you can put anywhere that you want. So I want to pick 11 right here for the spot drill. And then next, the tool number 12, I'm going to put the drill in there. And then remember, we're going to have the drill the live tool in order to make 2 flat on the parts. So we can pick whichever station. I can call maybe tool 7 to put the end mill in here. All right, you have to decide what side of the end mill that you want to use. Maybe, okay, 3/8 is good enough, so I can do 3/8 an inch right here. And square end mill if you want detail, more detail, right? And then the next thing, like I said earlier, we want to turn in the back side a little bit in order to leave just like less material for the sub spindle in order to working on. So we're gonna have maybe the next tool, we're gonna be tool number 3. It's gonna be back turning tool. So back turn tool. Okay, So this is all we need for the main spindle. Alright, in the back spindle, if you want to include in here, maybe you want a guide bushing. So the guide bushing size 1/2 inch. And also the main spindle also need the collet to hold the part too. So you're gonna need a collet. And same size 1/2 inch right here. So that's all we need for the main spindle. We're moving on to the sub spindle. So the sub spindle, in order to turn the OD, we're gonna use the left hand boring bar for this machine. And the reason why is you just flip the work coordinate system, and then if you see the left hand boring bar, it's gonna face and turn just like the right hand OD turning tool on the main spindle. So we're gonna say, okay, the left hand boring bar we're gonna use and put it in tool 31. So left hand boring bar. Okay, and then like I said, we're gonna need to spot it. So tool 11 is gonna be the spotted. Oh no, I'm sorry. We can put it right here. Tool 32 to spot it. Spot drill. And then next, we're gonna drill it so we can use tool 33. Alright, the last one we're gonna need is the tool, the threading tool, which is the number 34. Okay, also we said that we're planning earlier we're gonna need a collet also. So collet and side is gonna be whatever side that required for the sub spindle. In here, let me see, what is that? Okay, 315. So that is our plan for the tooling we're gonna use for this machine to do it. Okay, some people are gonna like do different way, and yes, there's many way to do one part and then to do a program, and then there's many way to complete the job. And then okay, I can go over another way for you, to make this part two. So the main spindle, we're gonna keep it all the same like this. But for the sub spindle right here, the spot drill and the drill right here, since we have the dog legs, it have the tool in the front from 11 to 14. In the back side, we have 51 to 54. So the spot drill, we can put it in 51 also. And then, oh no, let me see, it's 52, have to be 52. And then I will explain it later why it has to be 52 but not 51. And then the drill right here, we can put it in 53 also. Okay, so that's another way in order to make this part. So first thing we're gonna do is, okay, this machine has had a different G code in order to control the machine. The first G code that we're gonna learn later is the G630. So G630 allow the machine to work simultaneously front and back independently. That means both of them can work at the same time. So the main spindle can do whatever it do, while the sub spindle right here can do drilling spot, and no one has to wait for the others. So the idea is we saving the cycle time. So instead of running two different programs, we have to wait for the other program to be done. And then In this case, the G630 will allow us to finish what we need to do on the main spindle, while the sub spindle can freely do whatever it has to, and then complete the part at the same time, and then cut it up, done, and reduce the cycle time. And the second way we can do with this part is we're going to use G660, which is a little bit different, but this one is superimposed between the main spindle and sub spindle. That means you can use the dog legs in order to work front and back at the same time, but it has to call it parallel. That means whatever the location in the front you calling right here, it has to call parallel for the sub spindle, which is, all right here we use 11. Oh, so excuse me, I was wrong right here. I was right at the beginning, but I fixed it. So we're using the tool number 11 for the main spindle. That means if we're using the G660 right here, we have to use the other one right here as opposite side. It has to be matching, and it has to be tool number 51. Same thing right here. Since we're using the drill on the main is tool number 12, so it has to be tool number 52 on the sub spindle if we're using the G660. All right, so after we come up with the plan, we have to pick either we're gonna stick with G630 or we have to use the G660 right here. But then I'm not gonna let you choose because it's gonna be unprofit for you if you have to choose like either way, because you can learn only one way to do it. So now I decided to do both way. So in the future, you can use either way to do it. Okay, so the first way we want to do, so we need to lay out. We have $1. So we have G630 right here. Maybe let me zoom it up a little bit. Okay, and then we have $1 right here, and then we have $2 over here. Okay, since we agree we're gonna do both ways, so we go G600 first, 630 first. So what we're gonna do first over here on this side, so I will skip the safety block, whatever, the G50, whatever that we need right here, because we're gonna go over it later in detail when we make a real program. So right here, we just sketch it out, like how we're gonna process the program. So I'm not gonna go detail into the safety codes and stuff like that. I just say, okay, right here, first thing first, we're gonna use the tool number 2 right here to do facing. Next thing we're gonna do is we're gonna use tool 11 in order to do spot. And after spot, we can use the tool number 12 in order to drill it. And after we drill it, that means we're done with all the ID work. So we can go ahead and then use the tool number 2 again, but this time we're no longer facing, we're gonna do OD turn. So after we're done with the OD turning tool, next thing we're gonna do is we have to mill 2 flats. So that means we're gonna use the tool number 7 in order to mill 2 flat. Okay. And then, like I said, we're gonna do back turning tool, which is the tool number 3. Gonna do back turn. And last we're gonna do is just cut up and done with the main spindle. So G630 allow us to do work simultaneously. So while we're doing on the main right here, we can do at the same time in the sub spindle. And also I will skip over the safety codes and then jump right into the T number 31, which is the left hand boring bar. Okay, so left hand boring bar allow us to face and then finish the OD. And then after that we can spot it with the number 32. Spot it. And then after that we're going to drill it. After we drill it, we can do thread it. So we're going to use 34 to do OD thread. So OD thread, after you do OD thread, you can do is you can use the left hand boring bar to go back to deburr it. So next thing we're going to do T31 OD deburr. And then you can come back with tool number 34 again in order to deburr the thread. So thread rerun. And after that is completely, and then all you have to do is just eject the part. And then you're done with G600 mode. But then what you want to do is you want to do a last part programming. So which is we're going to go over it later how we're going to do last part programming. But right now we just sketch out how we're going to program it, how we're going to process in order to make the part with G630. Okay, so next thing we're going to go over a G660. Same thing, we have $1, $2. Process in the main spindle, we're going to do the same. T2 facing it. And then we have a T11 right here in order to do spot drill. And then we're going to use T12 in order to do drilling. And then same thing, we're going to do T2 in order to do OD turn. And then tool number 7 in order to do mill flat. And after that, we're going to back turn it with tool number 3. And after that, done with the tool number 1 cut off. Over here, the $2, it's just a little bit different. We're going to use the tool number 31 in order to face it with the left hand boring bar. But then we're going to use the T51 in order to do the spot drill. And then after that, we use T52 in order to drill it. And then coming back, after we're done with drilling, we can come back with T31. We can do T32 in order to know what tool that we're using for threading. 34. Okay. So we can do tool 34 to do OD thread. And then we can use the 31 in order to do OD deburr. And last, we're going to have 34 to rerun thread. Okay, and done with the ejection. So compare between two modes, it pretty much almost the same on the front side. But in the back side right here, we have a little bit change in the tool station. Okay, so you're gonna see it's the same, almost the same, but in the reality, when you make the program, you're gonna see it's totally different by using different G600 codes in order to make this thing happen, because we have to put like G630 on top right here and here, to do everything like this. And then the whole process, we're not gonna change the mode, but over this side we're gonna use G630 at the beginning right here, and then we have to change to G660 right here. And then after drilling front and back done, we have to move it back to the G630 in order to complete the parts. So that's the two different way we have to think about how we're gonna do it and how we can approach in order to make the part happen. All right, any questions so far?
So if you want to ask a question, unmute your mic momentarily. I don't see any questions, Han, continue.
Okay. All right, so after we already planning what we're gonna do on this machine, okay, the next thing we're gonna talk about, okay, what tool we're using, because tooling to using on this machine is one kind of really important too. Some people might be don't know, and then they might experience using the turning tool, which had the neck is sticking out like this. Which I can say, okay, on the switch turn machine or Cincom machine, we're not gonna use this type of tool. We will using the tool with the tip is flushing. All right. Oh my, excuse my drawing. So we're gonna use the tool with the tips right here. It's flushing with the shank of the tool. And the reason why is on the machine, this side of the shank right here, we have a Z0. So if you have the tip sticking out further than the shank right here, which is gonna be hard to program. Okay, either you're gonna have to use G50 in order to shift it. And then one more thing we have to concern is the distance right here. If it's more than 3 millimeter, we're gonna have a problem, because the tool is gonna run into the guy pushing. As we know it earlier already, the gap between the shank right here and the face of the guy pushing is 3 millimeter. So if we have the tool, and then in some cases, if you really have to use the tool, you don't have any choices, make sure the distance right here is less than 3 millimeter. If you have then more than 3 millimeter, it doesn't matter that you have to, and then you cannot use the tool. Because if you put the tool in, this face is gonna against the Z0, and then this sticking out, when you going down, it will hit into the guy pushing. So this is the no using on the Swiss lathe machine. Okay, so I'm gonna turn it back to, all right. going back to, that's right here. I see we have questions. Is that correct, Mr. Richard?
I don't see any questions. I'm asking anybody if they have anything.
Oh, that's you? Okay. Okay. So this one, we're gonna need to save the procedure that we've been talking about because we're gonna use it later in order to make a real program in order to run this part. And you guys can have a copy of the program later on in order to put on the machine and run and try it. But then this is how we're gonna process it. And next thing we're gonna go over, I don't think we, okay, right here, yeah. So this is gonna be another project for you in order to think how you're gonna like process in order to machine this part right here. Since this part right here, which is this right here. Okay, so we have a lot of feature going on. So we have to decide, okay, which way is going to be the first like machining, which is machine on the main spindle, and then which way we're going to do on the back spindle. So right here, I can say, okay, we have a lot of things turning right here. It requires a lot of ports, it's a lot of power. So I will put this side on the main spindle. And then, as you can see right here, we have the spot number 22. Oh, okay. Hold on. So this is another thing that we have in a different manual. So I will cross this one out right here. So I like to put the spot right here, tool 11, and this one, tool 12, instead of 22 and 23. Because this is probably using for the L20 machine, which is at the same capacity, but it has a little bit more function than this one right here, and it's using the Mitsubishi control. It's had more tool station. So go back to this part right here. We need to do is, for me, I like to do facing. So in the back right here, before doing the spot, I would like to do facing right here instead. So the facing, we're going to use the tool number 2. And then after that, again, we're going to do facing right here in the front. We do the spotting right here. And then after that, we're going to drill it all the way up to here. And then we're going to do facing. OD turn. And then after that, we're going to thread it right here. And then we're going to use the OD turn again, section right here. And then after that, we're going to mill it flat. There's 2 flat right here. And after that, we're already done with the main spindle. So we just cut it out right here. That's how we're going to process with this part right here. That's done for the main spindle. And then also the same thing in the back side. What we're gonna do is we're just gonna, I would like to add one more thing right here, is facing tool. So maybe using the tool number 34, so I'm not gonna messing up with it. So left hand boring bar right here. In order to give it a face, good face, before I can go in and drill it, and then bore it this out, and then thread it. And finally we're gonna eject the parts. Okay, so that's how we're gonna process and doing planning everything in order to make parts with this machine. Is there any questions so far? No?
What was that?
I just asked, is there any questions so far before we moving on? Okay, if not, we can moving on. So as I see, I expect that you are gonna have a questions, but since we don't, we're gonna moving on, but we cannot do anything to touch with the G600 because G600 we're gonna need the whole morning tomorrow in order to cover it. So I'm gonna go over something right here that we need to do with the machine. So this machine is a funnel control. So sometimes you're gonna use the machine in order to pick up on the different side of shape, but not a round shape. So what we have is right here is called a phase adjustment. So phase adjustment, we have two things to do. And what we're doing right here in order to have you to mill the part with different size and different shape. So for example, if you're gonna mill the hack side and then you're gonna pick up on the hack side. So you need to align for the main spindle and sub spindle in order to come in the right orientation to pick up on the sub spindle. The first way we're gonna do is we're gonna use the G899. You're gonna put G899 in MDI mode only. It will not working on the program. It only work on the MDI mode. So you turn on MDI mode, you put it in there G899 and then M26 on $1, which is the instruction right here. So after you cycle started, you run through the instruction right here, and then basically as we'll open the sub spindle is, and then you're gonna use the material go through the main spindle, go through the guide bushing, and then go over with the sub spindle and clamp on top of it. And after that is it's gonna synchronize between two spindle. We call it phasing. So either you're gonna use G899 to do this, or you can use the procedure down here in order to make it. So what you're gonna do is you're gonna go to preparation mode and then select the menu key right here. Press it until you see adjust right here. And after you hit adjust, so this table is right here, it will turn on. So when it turn on, you're gonna hit phase right here. So when you hit phase, and then the next thing, so this one is gonna come up. You just basically following in step, and then the thing that I want to say is really important right here is when you fed the Z1 is out here, you need to rotate the main spindle and sub spindle more than one revolution. So that way it's gonna tell the machine, okay, you trying to line up between the main spindle and sub spindle, and it's gonna work that way. If you don't rotate it, and machine is keep giving you alarm, or sometime the start cycle, it will keep flashing, and then will not give you go any further, and then you cannot like facing the spindle. So that's the only thing I want to put a comment right here, that after you fed it out the Z1, you need to rotate the main spindle and the sub spindle more than one revolution. Okay, so right here, I want to go over the last part, finished part program a little bit in order to, and then we can go back to the plan we have before and then do the last part program for that one too. So the last part programming is whatever the program you're gonna have during G999 and N999 is gonna happen on both $1 and $2. And basically what it does is, just imagine if you run one cycle complete without the last part programming, you're gonna have one unfinished part on the sub spindle. And if you keep running, for example, the quantity you want to run is about 1,000 parts. So if you run 1,000 cycle, so in theory, if no tooling breaking at all and nothing involved, you have good parts, you have machine running good, no problem. So at the end of the 1,000 cycle, you're gonna have 999 parts complete and one part incomplete in the sub spindle. So in that case, if you want 1,000 parts, and then you have to hit cycle start one more time in order to run one more part. But then if you have the material is really valuable, it's high price, to you pay a lot for material, you don't want to lose it. And then what happened is, either you're gonna like remove the material and let the main spindle running without the material to complete the back spindle, or in this case, Citizen provide one function is called the last part programming. So the last part programming, basically after you finish 1,000 cycle, and then you have the program with the last part programming, and you have the button on the control press for last part programming, the machine it will going back and then have the main spindle stop doing nothing, while the sub spindle it will come in and then finish the part. That's how the finish the last part programming gonna work. And then how we're gonna program it, we're gonna put it in the middle, G999 and N999 right here for both spindle. In the old way we can do is we can use the go to statement in order to look for the block number. So right here on the screen you can see go to H100. So when the machine is looking, see this one, it will jump into the block number that had N100 right here and run up whatever it has to do right here. And after that, from here, it will jump back to the 100 right here on top. So, and then 100 right here on top, right now it become, okay, 10. So it's gonna looking for the N10, which is right here, and keep going. But then for the new machine right now, you don't have to use the go-to anymore. You can use the M98 in order to call the sub-program. To program the last part programming, you have to use sub-program. You can like not using the sub-program, but then your program is going to be really long and it's kind of a lot of repeating. So using the sub-program right here, it allows you to program with whatever you need to do down here by the sub program only one time, and then you can use on top of it right here to run in the main program, and then also you can call it right here, which is with the M98 for the new machine right now, in order to repeat and run the sub program to complete with the last part programming function, which is going to save you a lot of time for setup, and then it's also save material. What I mean for the setup is, okay, if you have a part with the cycle time is really long, if you have the cycle time maybe like 1 minute, 2 minutes, something like that, you're not gonna really worry. But if you enroll with the setup and the cycle time running it maybe go up to an hour or something like that, longer than that. And then if without the finish the last part programming function, and then to complete one part, then you have to run 2 cycles, which is you have to wait 2 hours in order to have one complete part in order to check and then make adjustment whatever you want to do. So imagine if you make a mistake, because like nobody gonna say, okay, for the first time I set up, I will have a good part right away. So maybe you have 1 or 2 or 3 or maybe 4 like dimension. You need to go back and adjust and then run the program again. So without the last part programming, you have to run another 2 like cycle, which is a waste a lot of time for you to waiting in order to complete the parts, to see, okay, if you make adjustment correct or not. So with last part programming, you can finish one part, one cycle, and then this function you turn it on, and then the sub spindle will just go back, and then the main spindle just stay in one place while the sub spindle coming back and then doing whatever it has to do in order to finish the part. So instead of running like 2 cycle, now maybe you can run 1 cycle and a half. That means it can save you half an hour or even more than that. That is really a good function for me personally. But I can see a lot of people out there, they for some reason they don't really want to use this function, but in this case we want to force everybody to use this function since it's really useful and it saves you a lot of time for setup. All right, so since we already go over this one, we're gonna go back to OneNote. Give me 1 second. So right here with the OneNote right here, after we already go over the last part programming, we can do one thing right here. We can rearrange it and then we can reprogram, see what we can do right here. So everything, I'm going to erase the tool right here. Okay. All right, so in this case, we're going to talk about the G630 mode. So G630 mode right here, everything happen in the sub spindle right here. We can push it back down and then make a sub program. Maybe we can have it like block number N100 right here and bring everything down here. Bring everything down here. So right here, instead of have all the tool right here command, we can have is M98 and then H100 right here. And then cut off operation, eject is everything is already done. And then after that, we can put the last part program. It's just right here. last programming. And then also on this side too, we can have a last programming is exactly right here. And then after that, you can end the program with M2, M99. Over here, same thing, M2, M99. So that's how we planning to do with the G600 program and also with the last part programming too. Over here on this side, we can have it, since we use a different G600 code. So right here, this tool alone, it has to be one sub-program by itself. So maybe it has to be 100 right here. And then this tool right here, it's using a different G600 mode. So it's going to have a different right here. And then this one, since we're going back to the G630 mode, so we should have another subprogram right here. So we have 3 subprograms. So on top right here, we can have, okay, G660, and then we can call M98 with the subprogram number 100. And then we can have right here G630. And then right here G660, and then we can call the subprogram right here H20. And then right here, we go back to 630 right here, and then we can have another program, subprogram call right there. And all of this thing is going to go in here. All of this section is going to move out here. Okay, so then after we're done, we can put the G999 in here, which is the last part programming right here. Last programming. And then also same thing over here. We can put last programming over here. And then with last programming over here, it's going to be a little bit complicated than this side over here. So this side, in this side over here, you only use the G630. So in the last part program right here, you just have the G630 right here. And over this side, you just have to call it with G630 with the M98 to call the sub program. But then over here, since you have a lot of sub-program to call, and then you have to go same thing following the order what we use right here, G660. But then on this side, we will go over in the detail. So basically, we have to retract the material on the main spindle in order to have it clear why the tool on the main turret come over. I'll go over it later. But then we're gonna have over here also G660, and we have M98, M98 to call the subprogram over here also, and then go back, G630, what happened to me? Okay, and then go to G660, over here also G660, in order to call another sub-program right here. And then you go back to G630 over here, G630 over here, and then you call another sub-program right here. And then after that, you can end it with M2, M99. M2, M99. Okay, and that's how the differences between 2 ways we can approach one part with last programming completely planning to do. So do we have any questions?
Any questions? So I would just like to ask, you know, this is our first online event of this size, of this nature. You know, we've done classes for many years in class, in a classroom with, you know, 10 to 12 students on a whiteboard. And this is a very different experience for us. And we are just kind of wondering, you know, how are people, how is this coming across? Are people learning? Are people, is this making some sense in a format like this?
Well, I'm learning a lot.
Good.
Thank you.
I know it's a little bit of a different format. It's, you know, and you know, quite honestly, you know, from doing training myself for years, and you know, you could kind of read the crowd a little bit, read the students and where they're at and facial expressions, and you know, somebody's lost. But of course, that's a little bit difficult, you know, in this kind of a setting to kind of to see who's dozing off out there and see who's you know, who's picking up and getting you know, getting the gist of what's going on. So Hoan, I mean, everybody, so good comments, keep going.
I mean,
Everybody's
we
got front
already
row seats to the
reached
whiteboard.
the time for today.
So that's it for today.
Yeah, so if nobody have any more comments, and I would like to say, okay, it's enough for today, and we're gonna go to over the most important thing is the G600 code tomorrow morning. If you can have time in order to you know, attend the class, and I will see you tomorrow.
Can you see my screen at this point, Hoan?
Yes, I can.
Do you see the thank you for joining session 2?
Mm-hmm.
Okay. Hopefully everybody can see that. So I just want to reiterate tomorrow, 8 a.m. session 3. This will conclude session 2. So there was a little bit confusion about the links. So you should have received a link for every session. The link should be named with the session number. We had some people join session 1 again that was from this morning. Please click on the appropriate link for the appropriate session. So this will conclude session 2. Tomorrow morning at 8 a.m. California time, we will begin session 3. So it's just a new link, and we will just continue with a brief review of what we did yesterday, today, I'm sorry, and continue moving forward. I would like to thank everybody for attending. Thank you, Hoan, for the presentation, and we will hopefully see everybody back again tomorrow. Have a great evening.
Thank you.
Thank you.
Thank you.
Thank you.